Hello, in this video we will review material from section 7. This is the last section before our first test, so make sure you're looking over the practice test, make sure you're following the email directions, signing up for one of the testing windows. Also, if it doesn't work, make sure we're making, an alternative appointment, so make sure we take care of that. But in this video, we're going to go through section 7 again. We are solving the systems of equations algebraically, and I just put that note. That could also be called the addition method or the elimination method. Here we've got 3 problems. Again, take a moment, do them on your own, and now let's go through them together. Idea of the elimination method. There's not a, always follow this. The idea is to get rid of one of the variables, either x or y, and we do that by getting matching coefficients with opposite signs. So some people just always I'm going to eliminate x, but most of us just take a moment and try and see what is easier. Can I turn a 5 into a 3? Not easily. Can I turn a 3 into a 5? Not easily. But can I turn a 2 into a 4? Yes, I can. A nice clean times 2 will do that. I want matching coefficient with opposite signs. This already has the positive, that's the negative. So that's one move to eliminate y. So I didn't start off just saying I was eliminating y. I took a moment to see which one might be easier here. I made that decision by looking at the coefficients and realizing just one multiplier will get me to match. So I'll multiply by 2, but I'm not just multiplying that middle term, I'm multiplying everything by 2. I still have to maintain my balance. My new first equation, 10x minus 4y equals 24. My second equation is good. And now, the point of getting these matching coefficients is that now I add. And again, add is a little rough. I follow the signs. The like terms here, a positive 10x plus a 3x will give me a 13x. The like terms here, the minus 4y cancels with the positive 4y. Again, it's not just matching coefficients. If it was minus 4, that would be a minus 8. If it was plus 4, it would be a positive 8. I needed the opposite sign for that to cancel. Equals, and over here, 24 plus 2 gives me 26. Now I've got one equation left, but one variable. I've got 13x equals 26. Solving for x, I'll divide both sides by 13, and I will get x equals 2. Now that I've got x, pick an equation, plug in the value for x, solve for the value of y, the corresponding value of y. And this is where some people, again, just like eliminating x versus y, it should just be a moment or two we think about, is one easier than the other? And similarly here, when I go to plug x in, is one of these equations easier than the other? In this case, it's not really a big deal. Some people might just prefer to stick with positives, but it's no tremendous advantage either way. So again, not to get caught up making a massive decision, that really doesn't make that much of a difference. I'm just going to pick the top. 5 times 2 minus 2y equals 12. That becomes 10 minus 2y equals 12. Solving for y. Subtract the 10 on both sides. Minus 2y comes down. 12 minus 10 is 2. Dividing both sides by negative 2. Cancels here. Y comes down. 2 divided by negative 2 is negative 1. Last thing, put these together. Even here, I tried to keep my work kind of close, that like these together are the answer, but even better, make that clear. Put them together. That answer here at the end, putting that answer back up here at the top, whatever way you prefer, but that is your final answer. You want to check, make sure beyond a shadow of a doubt that you are correct. You check it in both. 5 times 2 is 10. Minus 2 times minus 1 becomes a positive 2. 10 plus 2 does give me 12. 3 times 2 gives me 6. 4 times -1 gives me -4. 6 minus 4 does give me 2. Again, I didn't put in the directions to check, but especially if you have some extra time or for your take-home assignment, definitely worth your while to check and know without a shadow of a doubt that that is the correct solution. And just the last thing before I move on, nothing special at all. Once I had the x equals 2, I very easily could have done that here. 3 times 2 is 6. Subtract the 6 to the other side. You'll get 4y equals -4. You'll still finish with y equals -1. Okay, now let's come over here, and I apologize, I scratched this off. So just up here, number 2. Now in number 2, I do that same initial move. Are x's or y's easier to eliminate? And I don't see either being easy. There's no quick way to make a 2 into a 5 or to make a 3 into a 4. So no matter what, I'm going to have to manipulate both equations. I need the common multiple. So again, once again, just pick. This time I chose to eliminate y's because I saw it was easier. Now I'm just going to pick to eliminate x. You don't have to write this, everybody. This is just for me, for my notes. That's where I'm keeping my focus. Some people, that really helps them to do that. But that's the point. I'm coming here. The only little advantage I might say for x is that at least I already have opposite signs. One negative, one positive. Over here, I'd also have to change the sign. But here, so what do? Well, 5 and 2 have a common multiple of 10. I'll multiply the top equation by 2 to get a -10. I'll multiply the bottom equation by 5 to get a +10. This is where some people start to think like, well, you just multiply the numbers by each other. Realize that would have been so much harder back here. Multiply this one by 2, multiply this one by 4. You're doing extra unnecessary work. It will get you to the right answer, but again, just taking longer, making your numbers bigger, increasing the chances for some basic, little arithmetic mistakes. So I'm just going to come down here again. Sorry for my mess. So I'll just come down here, multiplying the top one by 2. There's the -10x that I wanted, the negative sign and the 10, but I still have to keep going. I get a -6y from this. And then I get a -28 on that side. Now multiplying by 5, I get a +10x here. I get a -20y here. And then I get a -50 over here. Doing my arithmetic, that's what I wanted. Here I wanted to eliminate the y's. I noticed the negative positive 4y will cancel. Now I wanted to eliminate the x's, and I've got it. Negative positive 10x cancels. Keep going. Now these are both negative y's. Adding the two negatives, I get a -26y. Same over here, both negative. I get a -78. Again, that's why it's called, some people, the elimination method. You see the elimination, that's the key. Other people, the addition method, because the key is we are adding. Again, adding is a loose term. We're following the signs, adding, subtracting. So that's why you see it has the multiple names. But the key point, we're back on track. My numbers are looking a little uglier, but so what? Divide both sides, by -26. Still get my y. That's all that's left on the left as these cancel. Over here, well, a negative over negative is a positive. Looks ugly, but when you actually divide it, that's just a nice clean 3. We got y is 3. Make sure you finish. That's such a common situation that comes up. So many people, because there's multiple steps, there's a lot going on here, it's easy to get lost and forget that you haven't finished. You're not done. The point is to get an XY answer. We've got the Y, we still need the X. Take that Y, pick one of your originals, and just like we saw over here, there's no advantage. Neither of these are simple, so just pick. This time I'll pick the second one. 2x minus 4 times y, which is 3, equals the negative 10. I'm not using the times 5 equation. I'm going back to the original, just plugging that in. Well, that becomes 2x minus 12 equals negative 10. Add 12 on both sides. 2x equals positive 2. Divide both sides by 2. X equals 1. And now this is very common for a lot of people. Up here I was kind of working on a little left and right, so my answers were kind of close to put them together. Now just kind of working top going down. Now those two pieces are spread apart, but make sure we put them together. So at the end of the problem, 1 comma 3. And that last part, again, be careful. It always goes x then y. Here we found x first, then we found y. So some people, that's like a natural left to right. But here they found y first, so it's very tempting. They write 3 comma 1, but it always, always, always goes x followed by y. So 1 comma 3. And again, everybody, this type of problem, it's easy to work down, have your answer at the end. Some people, again, just like to underline, make that clear. I know plenty of other people prefer to go back to the top and to make it clear that's their final answer. I have no problem. A lot of you are seeing with your take-home assignments. Again, I'll find your answers. I know how to look through your work, but just at some point it should be clear. Make sure you're clearly identifying your answer. Last one, number 3. And now number 3, again, another mess. X's, Y's, there's just no quick, easy way. So here, this time, this is what I was trying to point out earlier. It's not just multiplying the numbers together where I had 2 and 5 with the X's. I multiplied this one by 2 and this one by 5. So similarly, people come down here. They don't see any tremendous advantage between X versus Y. They don't see any tremendous advantage. So, all right, I'll eliminate X just like we did up here. And they'll just go, okay, multiply this one by 4, multiply this one by 6. Or if you're eliminating the Y's, it gets even uglier. Multiply this one by 6, this one by 9. Again, I've already got the opposite signs no matter what, so that part's nice. But just a lot of work with the coefficient. But notice here, that's where, go a little smaller. Don't just automatically multiply by the other coefficient. Think about the multiples. The multiples of 6, 6, 12, 18. Hey, stop. 12 is also a multiple of 4. How did I get that to be a 12 times 2? Here times 3. Those are the magic numbers. Let's multiply the top one by 2. Let's multiply the bottom one by 3. I get a minus 12x from the top line. I still have to keep going. But notice going ahead, I will have a positive 12x, and that will eliminate my x's. So keep going up here. The 2 times negative 6x, negative 12x, 2 times positive 9y equals positive 18y. Such an easy goof. People only multiply one side of the equation, but you got to go over here as well. 2 times negative 3 gives me negative 6. Down here, 3 times 4, there's the positive 12x. Makes me feel good. I see that's going to cancel, but still keep going here. That's a negative 18y, and then I get a positive 6 here. I was aiming to eliminate my x's, and that happened. But coincidentally, while I was eliminating my x's, I also eliminated my y's. Number 3, we're looking at one of our special cases. But which one is it? Everything canceled on the left. That gives me a 0. Here, everything also cancels on the right. Minus 6 plus 6 does give me 0. 0 equals 0 is a true statement. That leads us to the infinite solution situation. But just really quickly, everybody, just to point out how easily that could have been the other one, let's go back up here. Pretend that was a 1. So now when I distribute 3 times 1 gives me 3. And now when I do this arithmetic, everything else is still identical over here. X is canceled like I wanted. Y is canceled in a very nice coincidence. But now 6 minus 3 would equal -3. 0 does not equal -3. That would be the no solution situation. So no solution, infinite solution. This front part is very, very similar, but it's all about what happens over here. You'll always get a 0 on this side. 0 equals 0 is true. That's your key, that it's an infinite solution. But over here, it's nothing special about this digit. Again, keep changing the number. If this was a 5, well then this is a 15. -6 plus 15 equals 9, but 0 still doesn't equal 9, still gives me the no solution case.